the number of flip-flops which are closer to this. When you want mod 3 counter, how many it should count? It should count 0, 1 and 2. After 2 what should happen? Again it should become
0,
1 and 2. And this sequence should be repeated. Now that means what? If you take, now how do you decide how many number of flip-flops you need? If you take 1, how many you can get? Only 2 you can get. If you take 2 flip-flops, you will get 4. But you want in between. You don't want 2. 2 is less, 4 is more. So you cannot take the number of flip-flops to be less than the actual count. You must take only the flip-flops which are more than the actual count. And suppress those counts which you do not want. So if you take 2 flip-flops, you have 0, 1, 2 and 3 accounting to 4 possible states. But what do you want up to? Only 0, 1, 2 only you want. So this has to be suppressed. So always it is a better practice to take the number of flip-flops which are greater than the count, actual count, and suppress or remove those counts which are not required. So you take 2 flip-flops, you get 4 counts and suppress what? That last count. These are the 4 counts. So now how do you do this? Take down the logic diagram. First step is that you need 2 flip-flops. You need 2 flip-flops and the truth table, and when you take the truth table, you have Q0, Q1, the decimal value 0, 0, 0, 1, 1, 0 and 1, 1. This decimal value is 0, 1 and 2. And this is the 3, the third count, and that has to be suppressed. That means when Q1 is 1, Q0 is 1, this should not be counted. Instead it should count it as 0, 0. Do you follow this? We don't want this count to be coming, we want it to be suppressed. So for this what do you need? Take down, see the arrangement here. This is your J0, this is K0, Q0, Q0 bar, J1, K1, Q1, Q1 bar. We connect a feedback here, let us see what happens.
Okay.
And these two are joined. This is equal to 1. Let us understand the logic here. So Q1, when it is high, Q1 bar will be 0. When Q1 is 0, Q1 bar will be 1. Because Q and Q bar are two complementary outputs. One is a complement of the other. So now what is it that you have to do? See the timing diagrams. Let me take 4 clock pulses, and the clock that you are giving is
0.
Parallel clock. That means clock is simultaneously applied to both the flip-flops. And one fundamental rule is when you are constructing these counters like mod 3, mod 5, which cannot be expressed as 2 power n, they can be constructed either by asynchronous type. We have seen 2 types, asynchronous and synchronous. They can be constructed using asynchronous, or can be constructed using synchronous, or it can be a combination of synchronous and asynchronous. You cannot have completely asynchronous system or completely asynchronous system. In some cases, some modulate cannot be expressed completely. So you can have both. In this case, we are using what system? It is a synchronous type because clock is commonly given to both the flip-flops. So now this is a negative edge trigger. 1, 2, 3, 4. This is a 4, third, second, first. Now what happens to Q0? Q0 is initially to start with, this is 0 until the first clock pulse comes. Q1 also is 0. That means we are assuming an initial condition that all the flip-flops are reset to 0, and you are starting from it. Therefore, this is 0, this is also 0. When the first clock pulse comes, when the first clock pulse is applied to J0, K0 is already 1. When J0 is also 1, what will happen? J and K being equal to 1, it constitutes what is known as toggling. When J is equal to 1, K is equal to 1, first flip-flop will toggle from 0 state to high state and remains on till the next clock pulse comes. Then let us see what happens during this transition from 1 to 2. Since initially before applying the clock, Q0 was 0. This is transferred to as 0 here to the J flip-flop. So this continues to be 0. So this is 0, this is 0, this is 1, and this is 1. When the second clock pulse comes, pay attention here. When the second clock pulse comes, during that time what is happening? Prior to second clock pulse, what is the state of Q0? Prior to high. Prior to second clock pulse, Q0 is high. Isn't it?
Yes,
is it high? Q0 is high, J is going to be
high.
Already K is 1 here.
Both are high.
J is 1, K is equal to 1. It allows the flip-flop to toggle. Therefore, Q is, prior to that is 1, then it will go to the 0 state. But when Q is high, what's happening to Q bar?
0.
Q bar is 0. Where are you connecting Q 0? Back to J0. This is your feedback. So during this second cycle, what is happening? J0 is made to 0. So this will go down, remain so until this time. But here what is happening? 2 goes high until this time. So what's happening? Q1 is high. Q1 bar will be 0. So when the third clock pulse comes, the 0 is fed back. Therefore, it continues to be in the same state. During this time, this Q0 is 0, Q1 bar is 1. So 1, 1, it will allow it to toggle. Does it toggle or not? Prior to this, this is 1. Okay, and this continues to be like this. So this is going to be 1, this is going to be 0. Then at this point, what is happening? At this, before third, Q0 is 0, this is 0, this is 0. Q1 is again 1. And this is 1, that is going to be 1. Then this continues to be as 0 and Q1 goes like this. And again it goes. So this is going to be 0, this is 1, this is 2, this is 0. Again it rises here, 1 and 0. What's happening here? At this point, why is this resetting? Because Q0 is 0. Q0 is 0. It transfers this to 0. This forces Q1 to 0. So it is going to 0. Prior to that, Q1 was high. And Q1 bar is going to be 0. Prior to the third, what's happening? Before this goes down, Q1 was high. When Q1 is high, Q1 bar is going to be 0. That 0 is fed back here. Therefore, Q0 continues to be in the 0 state. That is why instead of rising here, it continues to be in the same state. So what is the count that is counting? 0, 1 and 2. And this is 8. Number of clock pulses required are 4, but the counts are only 3. Then, why is it? What is happening? Why is this becoming? When 1, 1 comes, the next count is 1, 1. When 1, 1 comes, what is happening? At this point, Q1 was 1, Q0 is 1. When the state comes here, next sequence when it comes here, Q1 bar is going to be 0. So therefore, this forces this to J0 is 0 means this becomes 0. Once this is 0, because this is connected to J1, Q1 also is going to be 0. And hence, it continues to be in the 0 state. When the next clock cycle comes, when this is 0, this is 1, 1, 1, again starts toggling and the cycle will continue. So if you draw 3 more clock cycles, for 3 you are getting 3, 0, 1, 2. If you had drawn 4, 5, 6 clock pulses, you would have got 0, 1, 2 to have been repeated. Is it clear?